Wait for it. All right, we're live.
Awesome. Welcome, everyone. I'm Mario Loria, and the people on this call are Bob and Jeff and George, who help me with Orchestructure. This is the Orchestructure. What month is it? It's July. July meetup 2020. We are still alive and well in our homes. Today, we have a special guest who's come and actually spoke at the Ithaca headquarters, and not headquarters, but offices in Ann Arbor last time, and graced us with Helm 2 and what was coming next. Today, we're proud to have Matt Farina, a close friend, confidant, and someone we really love in the Kubernetes community. He is a key maintainer of Helm and definitely someone who has many great opinions, thoughts, and ideas around the future of Kubernetes, application package management, and so on and so forth. I wanted to quickly say that we are streaming on YouTube, and we are very much alive and well in the Orchestructure, #Orchestructure channel in the main A2 Slack network. So please feel free to ask questions, leave feedback, and any comments that you have for Matt. And I think we'll probably save some time for just kind of back and forth and doing questions as well at the end of Matt's session. So we are going to take the month of August, next month, off. There will be no event, but we will be back in September with another recurring visitor, Nicholas Click, who will be gracing us around the enabling GitOps with the GitLab Kubernetes agent. That is the title of his event, which will be announced momentarily. So we look forward to everyone enjoying this session. There will definitely be a recording, I think, possibly, maybe. Obviously, I think the YouTube, yep, thank you, Jeff. The YouTube should have the recording after we are completed. Any resources and other things that Matt has, we'll definitely share with everybody after the event. I am so proud to introduce a great friend, Matt Farina. Go ahead, take it away.
There's my unmute button. Hello, everyone. Welcome. So today I'm going to talk about Helm 3, that wonderful thing that came out a little over 6-7 months ago now. Helm 2 is nearing the end of its life, and so we will be entirely done with it, supporting it in November of this year. So now's the time to start transitioning if you haven't yet. And I'm going to talk about Helm 3 today. You're going to get a little bit of color commentary, some history, maybe a little rant. You'll get to know what I think, and then you can ask me questions, and I'll try my best to either answer them or make something up. There we go. For those of you who don't know me, hi, I'm Matt Farina. I'm one of the 3 Matts who work on Helm. There's Matt Fisher and Matt Butcher as well. I work over at Samsung SDS. I maintain Helm, I do Kubernetes SIG Apps, I do a number of things, but I'm here today to talk about Helm. And why isn't it going? There we go. So I figured I'd start in the beginning as I get into architectures. Helm version 1. This originally came out of days about 5 years ago. And Helm version 1, its system actually talked to Kubernetes directly. There was no tiller, nothing like this. This is before deployments, before config maps, before secrets, any of that stuff. And Helm talked directly to it. Now, it had its shortcomings, but it got really popular really quickly. And then there was this project called Deployment Manager, which was part of Kubernetes before the CNCF existed. And Helm and Deployment Manager came together to create Helm version 2, which is where tiller came into the picture. Now, tiller is the big thing in Helm version 2, which caused some gnashing of teeth. Some people liked it. Some people just didn't like it. And it caused issues. Now, tiller, for the history of this was around before custom controllers. Helm version 2 was out before secrets were generally available. This is actually quite some time ago. The Kubernetes ecosystem has progressed and it's changed, and we've learned a lot. When Helm came out with tiller, there was no RBAC. And so the issues that came with RBAC and with the different namespaces actually weren't there when Helm v2 came to the world. And so where tiller was a great idea in the beginning, and it worked really well to keep things consistent in the cluster and allow multiple clients to talk to Kubernetes and to just have that agent there. And this was actually an artifacted deployment manager as Kubernetes changed over time, as things changed, it actually became more of a liability. And so with Helm version 3, the Helm client talks to Kubernetes directly again. There is no need for Tiller or the security models or anything else that went around it. This was one of those things that with Helm, we cut our code base about in half, and we removed a whole bunch of bugs that came in with gRPC communications and just having to deal with that and upgrades and things like that. So it actually made Helm more stable as well. This also means that you can use normal user credentials. Those credentials that you use with kubectl, that exact same stuff, your kubectl, you can use that with Helm today. And so 2 or 3 or 4 users who are communicating with it, instead of having that Tiller client that has its own set, and then you're stuck with everybody using that authentication and authorization. Now, everybody who engages with using Helm in the cluster has their own authentication and authorization, and it works the same way the rest of Kubernetes communications do. This simplified our model so much, it made me so happy. The other thing that we do is something that may be a little different for some, is we store the release information in a secret in the namespace by default. Now, you can choose to use a config map if you want. Secrets were not used in Helm v2 because they weren't GA when Helm v2 came out, and Helm is big on backwards compatibility. Now, when we came to do v3, our first thought was actually we were going to do a CRD and custom resources. But it turns out that a lot of people who use Helm or want to use Helm, the people who would install the packages actually don't have permission to install CRDs in a cluster. And so having Helm install and use a CRD was actually going to become a blocker for people using Helm to install packages in their clusters. There's just a lot of places where the cluster operators aren't giving that access out. They're a little bit strict on it. And so we went with secrets because we found pretty much everybody had access to secrets, and it worked well because secrets can be typed. And so Helm uses a typed secret that says, hey, this is Helm, and it's got our domain name in it, and it says it's a release, and it's a versioned in the type. So if you actually use kubectl to look at the secrets in your namespace, you'll see the typed secret there. And you're actually going to see the name of the secret uses a reverse DNS notation to specify that, hey, this is Helm, and it's a release v1. So that way, release secrets that may have been used in Helm v2, which was an opt-in option, you don't run into collisions. We actually ran into collisions in testing, which is what caused us to do this. But we use secrets to try to expand who can use Helm. And we really thought CRDs were going to be the answer, but they turned out not to be. Which reminds me, a quick little sidebar here. If you didn't know this, you can encrypt your secrets at rest. This is another thing, because some folks with Helm charts and things like that will want to pass in, say, a password for something. Say you've got a WordPress chart and you want to set your MariaDB password. You might go ahead and set it, make it stored in the values, which gets stored in the release object. And secrets in general, they can now be stored encrypted. And so if you're doing that, it's a good idea to encrypt it at rest if you can. There's more than one way to do it. The Kubernetes docs will tell you how. But I think this is an important, and this is also an advantage of using secrets, is if secret information is put in there, then we fall back on the Kubernetes security model and the security model you use for the rest of your cluster, rather than Helm doing its own thing. Another thing that was in, or that is in Helm v3, is a 3-way strategic merge patch. In Helm v2, we would take the old manifest and the new manifest, and we'd go upload things, but we didn't take into account the live state. And that caused tons of problems. If you made changes in what was running in the cluster, yeah, that could be an issue. And one of the simple answers to this is a sidecar container. So people like service meshes, my cool service mesh. I won't name names because people fight over it. But if a service mesh made a change in a 3-way, that wasn't caught. And when you did an upgrade, Helm v2 would just blow that away, and your service mesh is now broken, your stuff's now broken. It wasn't compatible. And there were other cases, but I think service mesh was one of the big ones. And so we're now using the 3-way strategic merge patch, that same thing that kubectl does and gives us the ability to do. We're doing the same thing in Helm. And so we will calculate that diff and make a change. And so if your sidecar container added a container that's monitoring things, we don't mess with it anymore. And so that's another advantage in Helm v3 to dealing upgrades when you got some of the more complicated systems. So I want to talk about additions to charts. Charts changed a little bit in Helm v3. Helm v3, for the most part, supports Helm v2 charts. There's a couple nuances where things don't work quite the same. And I'll actually touch on how to work around that in a minute. But for the most part, your Helm v2, okay, so Helm v2 charts will work in Helm v3. Now, this is where you get a little caught up. So a Helm v2 used the chart API v1, and Helm v3 uses the chart API v2, right? So chart API v2 doesn't go with Helm v2. It goes with Helm v3, and I can imagine that's a little bit confusing. But let's go take a look at some of the additions that we added to charts and some of the neat things you can do with it because of that. The first thing you got to do is if you're going to take advantage of this, set the API version to v2. Although it's not going to be compatible with Helm v2, these changes, but come November, Helm v2 isn't actually going to be supported by the Helm project anymore. And so the transition time's coming up, which I'll talk about migrating in a little bit. All right, so the first thing, dependencies are now in the chart.yaml file rather than being in their own requirements YAML file. If there's a requirements YAML file there, Helm's totally going to work with it, and it'll calculate a requirements lock file. But if you have them in your chart.yaml file, you're actually going to have a chart.lock file instead. Otherwise, it's the same kind of information that's calculated in it. Same thing where you can specify a version range and then use Helm dependency update in order to calculate out the latest lock and all that stuff. Same functionalities there. It's just now moved to the chart YAML file, because why have a ton of files? We can store it all in one. So that way you don't have to bounce all over. In fact, that's one of the things we've been talking about lately is people have ideas on extending Helm charts. Like, ooh, let's create a new file to hold this information in. And I think one of the trends we're settling on is try to put it as much of it into the chart YAML file as possible. So you don't have to know all these different config files and stick stuff in different places. It can all be in one location. And your chart.yaml file is typically a lot smaller than any Kubernetes manifest that you're going to deal with. And so it's not too bad in reality if you're talking size. In fact, I think, I don't know that I've ever had a Kubernetes YAML file that was shorter than a chart YAML file. The next thing is we have a new thing here, library charts. And library charts are charts you can use as a dependency, but their assets are not going to be rendered and sent to Kubernetes. Everything they've got is meant to be imported and used in your chart. It's a way to basically have a library imported into your application and then reuse bits and pieces of it. In the stable repository, Adnan, who was over at Bitnami and then VMware, and now he's at Brex, he started this thing called the common chart. And it basically had a whole bunch of templates you could import into your chart and just reuse them. And it did a bunch of work for you. You only had to pass a few things in. And it could do a lot of the generation for you. And so it was really easy to have 5 different charts, just use as a library, just fill in a couple of details, and the library did all the work. Now, we were not able to move it into something that's stable because in Helm v2, it tried to render, and then you might try and stick some of the stuff you could actually install the common chart into a cluster, and that ended up in a broken situation. And one of Helm's tenets is, we don't want to break you. There are a lot of people out there who approach Helm and Kubernetes who aren't Kubernetes experts, like those of us who are on this meeting today, or this call today. And they don't know, and they're very early on, and we want to make it so they don't break themselves. They don't break their situation. And so we didn't want to move the common chart there. And so in Helm v3, we made this idea called a library chart. And its inspiration, I want to say, was Composer and PHP and Packagist and all of that, because that's one of the options is they have different types of packages. And that was the inspiration for this. And so now we've got the default is application. And so you don't have to specify anything to get that. But if you set your type to library, then we won't render those. You can just import the bits. And it also gives us another abstraction. Whereas if we come up with another type of thing other than an application or a library, we have that point of extension now in Helm to support other things as well. JSON schema. So JSON schema will let you specify a schema and then validate against that schema. right? And it works on JSON, but because YAML is a superset, you can actually convert back and forth. We do it all the time in the Kubernetes world under the hood and things like that. You can translate back and forth. You can actually use it on YAML files. And so you can have a JSON schema that will you can define your values YAML file, and then Helm, when you run Helm install, Helm upgrade, Helm lint, those kinds of functions, Helm template, it'll actually validate the values passed in to make sure it's it. So in this example here, right, I have something called image, and it's got a property of pull policy. And I've said, hey, you're an enum. It can only ever be always or if not present as the values passed in. So if somebody were to fat finger and misspell always or misspell if not present, when you try to go Helm install, it'll actually throw an error in validation and say, hey, it can only be one of these two options. You didn't send that in. And so you can define a JSON schema for all or part of your values YAML file. If you do just the part, then it'll just validate that part and the rest of it won't get validation, or you can do the whole thing. But it'll let you start layering in schemas, and then Helm will actually catch that along the way and give people errors. And there's a number of things you can do with this. I like enum because it'll list out the options. You can only do these, but you can actually do things like regular expressions as well. And so you can say it's must match this regular expression. So you can check for URLs, you can check for email, all those kinds of things you can actually do here. And so JSON schema lets Helm now do a certain amount of validation. But that's just one of the benefits of JSON schema. But before I get to that, right, if I had a values YAML file, oh, no, sorry, before I get to that, you can actually take the same JSON schema, and there are tools out there that will generate a user interface off of it. And I just took a screenshot of one of the tools for React, but you literally give it a JSON schema, and here they give it a little bit more information like your form data and things like that to fill in values. But you can actually generate a form just from a JSON schema. And so one of those things that was always desired, and I want to say the Kubernetes folks wanted it, was they wanted to take a chart and then generate a form where somebody could fill in information, hit submit, have it install in a cluster. Their thing was actually just to pull up the values YAML file and let people edit and manipulate it in their installation tool. But that's not elegant, right? And a JSON schema gives you enough metadata that you can actually generate a form, collect that information, pass those values into Helm along with an installer, and do a bunch of magical stuff on the fly. And so that's another benefit of JSON schemas. In fact, if you only want to expose a certain amount of information, you can create a JSON schema with just a subset of it, like I was talking about. It'll validate against that subset, and you can create the form off that subset. It's a really neat way to kind of enhance and be able to build more onto this stuff. And if you don't want to deal with the structure of a JSON schema of generated for your values YAML file, there's a plugin for that. One of the folks who's been contributing to Helm in the last year or so actually created a tool, and this is the GitHub page for it, and it's a Helm plugin. You use Helm plugin install to install it, and it will generate a stub JSON schema. A lot of your stuff's just going to end up with basic fields like strings and doesn't have the validation on it, but it'll give you that basic structure, and then you can go fill in the nuance you want, and you've got that structure in place. And the direction of how to use it are all on that page. But it's a great way to get started. And quite frankly, this is what I use because I don't want to go write the JSON schema. I'd rather just run a function, have it be generated, a command, have it be generated, and then go tweak it. And so this is what I use. It's the easy way to go. All right, CRDs. CRDs are a pain in Helm. They're a pain in general. And so I want to talk about CRDs. This week, we ended up in the Helm, some of us maintainers were discussing quite a bit, trying to figure out, we haven't put out our stance on CRDs. That's actually going to be coming soon. I'll talk more about that in a minute. But CRDs are hard. CRDs, it turns out, are really hard, especially if you have a general tool. Yeah. And so I want to start with something here. Brendan Burns wrote a retrospective on CRDs and where they came from, talked about their history and aggregated API servers and things like that. And so one of the things he talked about was he laid out, here's what CRDs are for, right? Provide an easy mechanism to dynamically add new API types, right? To enable extensibility, and here's the thing, without significant additional load. Now that additional load has to do with the aggregate API servers, which is a real pain in the neck if you're an operator consuming things and getting to do it. The Kubernetes service catalog was built on that. It's just complicated. It's painful if you're an operator, right? CRDs are easier. You don't want that extra load. And notice it's the operators of Kubernetes clusters rather than the people who are installing apps and workloads, right? And to enable an ecosystem of plugin providers who can produce and distribute. This is really all about extending Kubernetes. And I know we use CRDs a lot when it comes to applications and workloads and things like that, but in that original design, it wasn't there. And so there's a ton of stuff lacking, and I'll get to that in a minute. But you can actually see here that how they were envisioned isn't necessarily how they're used on a daily basis. CRDs to me are more like kernel modules or extensions rather than user land applications, if that makes sense. At least that's in their design. That's in the design. That's the way they're put together. That's the policies around them, the workflows that we have, the kinds of checks and balances that are on it, right? And of course, because they were designed this way, if you go look at the documentation, it'll tell you how to extend it, but it doesn't tell you how to deal with workflows. This has actually been an ongoing problem for us in general. A while ago, I went and I started poking around as part of SIG Apps to see if could I figure out a workflow because we're trying to do this stuff with applications. And it's like, but they're cluster extensions. They're not application stuff. And like people use it that way. And so people will say, well, they shouldn't. And the workflows that you can use aren't documented. So like imagine a multi-tenant cluster. One person installs the CRD. Other people in that multi-tenant cluster start using that CRD. That person who installed it says, I'm done with this. I'm going to delete it and clean it up. They delete the CRD. Everybody else's custom resources are then deleted. They're gone because that's what Kubernetes does. It deletes all of it. And one of the things we do in Helm is we don't want to break the users. We don't want to break that experience. And these are the kinds of situations that are going to come up, that do come up, right? How do we deal with a situation where somebody who wants to go install a chart doesn't have permission to install a CRD, right? Because people have cut that off. I talked about it earlier with Helm in general, just for Helm use. But there are people who want to go install packages that have CRDs and they can't, they don't have permission. What about upgrades, right? So you got your different API versions are in that CRD. What if somebody says, hey, I'm going to go change the schema to one that's already deployed? Okay, go change the schema. You can do that in a backwards incompatible breaking way at the same API version. Totally works, starts breaking people in clusters. I've actually seen this happen before. And I said, why didn't you increment the API? He goes, oh, I probably should have. I didn't really think about the other users. I've actually had that experience with somebody before, right? And these are all ways you can hurt yourself with CRDs, and there aren't checks and balances around it. And there's a bunch more, but this makes it hard to build general tooling on top of it that does stuff because there aren't recommended workflows. There aren't nice ways to do it. And so for those of us who are trying to build tools that are general tools, it's just hard. And I know some folks have made a whole bunch of assumptions about this is how things will be used and installed, and then they deny other possible workflows. And some people will use those other workflows with Helm. And so it's hard for us to build just that general kind of tooling. Sorry, I just had a bug flying right here. So it's hard. It's difficult. CRDs present a problem that we want to work through. And every time somebody comes up with a management philosophy and they come to Helm and say, here, this is what we'd like to do with CRDs, we're able to punch holes in it to show examples where it doesn't work with real world situations of people using CRDs because somebody made a bunch of assumptions of how they want to use CRDs. And they're not taking into account how other people want to use CRDs. And that makes it really hard because with Helm, we're not making assumptions that pigeonhole people into just certain ways you can use them. And so we're very open to discussing and working on this stuff. It just turns out it's hard because CRDs are so flexible and offer so many opportunities to hurt yourself that they're hard. But with that in mind, we actually have two ways you can do CRD stuff with Helm. So that's the end of my rant. That's the end of my rant on CRDs and their pain. Let's talk practical stuff of what you can do in Helm. The first method is to use the CRD directory that is now part of the V2 spec. Helm version 2 will just ignore the CRD directory, and you can take non-templated CRDs and just stick them in here on the CRDs directory. And Helm, when you run something like Helm install, will go ahead and do an install if the CRD is not already installed. If the CRD is installed, we're not going to overwrite it because we don't know the difference, how to calculate. What's your intent? Is the intent an upgrade? Is this an accident where somebody has a newer version and somebody's now trying to install the chart with an older version and you're going to overwrite newer CRDs with older ones? We can't calculate that. And so here we're making the call that we'll do an install if it's not there, but otherwise we're not going to do anything. And the reality is you can actually extract the CRDs from the chart, pipe them into kubectl if you want to do that. And with a second command and a little piping, you can actually just move those CRDs in and do the upgrade as well. That's okay. But Helm is being very conservative in this to stop people from hurting themselves. And this is one way that you can manage CRDs. Now, you'll want CRDs probably across Helm v2 and Helm v3 for a while. And so the way to do that is actually to have them in the CRDs directory. And in Helm v2, there was the CRD install hook. Just have a second set that's got the CRD install hook. One option that you can actually do is use the files.get, and you could just say, hey, if it's on Helm v2, go ahead and read the files in the CRD directory into the templates directory. You can actually use templating to pull them in and only have a copy in one place. And one of the reasons they're not templated is they're actually global shared resource. This isn't the kind of thing that's going to be customized per application. And it's easy then to extract them so you can pass them off to an administrator to install, or you can figure out how you want to handle and check for upgrades, and you can come up with some of your own policies on that. That's the reason they're easy to get out and just apply with other tools then. So that's method one for doing it. It's kind of the simple, more conservative method. The other method that we have for CRDs is actually to break things up into two charts, but don't tightly couple them as dependencies. In one chart, have CRDs. You can have them in the CRDs directory, or you can put them in the templates directory and fully template them. And if they're in the templates directory, then Helm will actually manage the life cycle. So if I did Helm install my CRD package, and Helm upgrade my CRD package, and Helm delete my CRD package, it'll actually do all the things you normally expect, but it lets you install just the CRDs separately. And then have a second chart with the things that use the CRDs that's installed. And one of the things you can actually do in that second chart is you can use template functions to say, hey, if the CRD is not installed, throw an error and tell people to go install this other package first. You can actually do that and just stop it in the templates itself to run that check. And so it's possible to install the CRDs and manage them in one way, and then install the charts that use them a second way. In this, well, it gives you that ability to have the Helm management. It also kind of stops you from being able to hurt yourself as easily, because let's say your thing that relies on it, you need to uninstall and reinstall for some reason, right? There's a problem. It's like, oh no, I need to uninstall the chart and reinstall it. Or maybe somebody accidentally is going to delete that. What you don't end up losing is everything that's in your cluster, right? You can uninstall it safely and reinstall it, and all those custom resources are still there. So it gives you that safety by not having the hard dependency. And so this is the other way to do it if you want Helm to manage everything. It's a two-step process to do it, and it still gives you that Helm control. But these are kind of the two methods we have, because you're really installing that cluster extension in one step and then the stuff that uses it in another step. In fact, you can have more than one tenant install that second thing that uses those global custom resources, because they are shared in that way. So that's what we've kind of come to on CRDs at this point. If people want to talk to me more about CRDs, I'm very happy to. It's just complicated and hard, and people have been trying for a while to come up with good general ways, and there's no guidance out of the Kubernetes community, so it's hard for us to come up with good direction as well. All right. One of the things that we will be doing in the near future, and I actually took a to-do on it yesterday, is the documentation around CRDs that talks about some of this workflow, like piping things to kubectl, and both the methods that I talked about today are actually documented already, but a bunch of the extra and the reason for it, we're going to go update that documentation. It's probably a few weeks off before I can get to it, but I did sign up to do that. So we'll be expanding on it for people who need to know why or how, or even just have some quick, friendly copy and paste, simply modify commands. We'll have some more of that in the documentation in the coming weeks. All right, so I want to talk about Helm Experiments. One of the other things to Helm v3 is we added the ability to have experiments in Helm. Helm uses semantic versioning, but sometimes we want to try something out and not have it be part of the Semver contract. And we never know what will come of it or where it's going to go. So we wanted to have that capability. And we use environment variables to enable it. And the first thing we did was OCI registries. So the OCI has something called the distribution spec. And a bunch of the repositories out there, the container repositories out there, hold to or are close to the OCI distribution spec. Now, not everybody is, right? Some of them intentionally say you can't do some of the things of the spec, and Docker Hub happens to be one of them that says you can't. But some of the other ones and Docker distribution end up following to the spec right now. And one of the things that you can do, although will they give the thumbs up on it or not is still wait to be seen, is stick other things in OCI distribution registries that aren't container images. I expect it to be coming here because there's a large contingent of service providers who are actually building tools that stick other packages into OCI registries or OCI compliant registries. So I expect just the windfall to just move in that direction. And that's actually one of the holdups of Helm keeping it as experimental and not moving to production yet is we're waiting for the OCI to say, all right, we officially give a thumbs up on this, because otherwise we're building a hack on top of the OCI stuff. And we really want to have their blessing to do it, right? We don't want to be going outside of what they say you should do and its intent in an official feature. We're also going to be redesigning this in a little bit to make it work with some of the existing workflows. You're actually probably going to see charts, the Helm chart command set go away as things are just moved into other commands. Save, pull, push, all of those things are actually going to be moved mostly into pre-existing commands, like the ability to pull a chart from OCI. We can move that into the Helm pull, which used to be the fetch command. Things like that are going to move around to simplify the experience and make it a little bit more concise. But we are moving forward with this, and you can take a chart and you can stick it into an OCI registry, just like you can an image with this feature set. We haven't done provenance files yet, but that's actually coming, and there'll just be another layer in there. And so instead of using the Helm repositories, or even having to run a Helm repository in an OCI registry next to your container images as another thing in there, you could say, here's my chart. And then you could just upload your charts and your versions and things like that there and pull them down the same way that you do your images. And our hope is really that this is the future. Some of this is really just dependent on the slow process of working with the OCI and the service providers to make sure we're all in lockstep with things working together. And that's just going to take some time. So that's the experiment we have now. And I'm actually kind of excited about the OCI stuff because we could deprecate more code in the future, right? And move into more common systems. It'll be interesting to see what they do with OCI registries, because in many ways it's almost like a bland object storage with a more complicated API and a stricter set of things as people want to put things in there. But I expect we're going to see more things end up in OCI registries than images and even charts in the future. All right, so let's talk moving from Helm v2 to Helm v3. This is a long process, and I created a whole section on it with one slide. All right, so in the process, we decided that we were going to automate the upgrades, the upgrade from Helm v2 to v3. And it wasn't baked into Helm v3 because you're going to do it once if you end up doing it that way, and then you don't need the code, and we don't need to maintain that code as part of the Helm v3 API in perpetuity. And it lets us kind of iterate here as we learn more about what we need to do about it. But right now there's a plugin you can install, and it'll upgrade two things. One, there's your local configuration, like your plugins and your repository config. That actually moved to a new place in Helm v3. That's one of the things I didn't really cover. It used to be in the .helm directory off of your home, but on every operating system, there's a standard place to put that, right? And Mac, it's in the library. Windows, I want to say it's the app data. And on Linux and POSIX systems, you're probably going to run into XDG specifying locations. If you don't know XGG, it's a kind of a spec for where you stick things. But there's these standard kind of locations on every system that things are supposed to go. And so Helm v3 kind of embraced, put it in the standard places where things are supposed to go. And so the plugin will say, ooh, we'll take that Helm v2 configuration, we'll move it to the new location for you on your system. And it's a copy. So it copies it over there for you. The other thing that it lets you do is upgrade your releases in your clusters. So you can point it at a chart you have installed, an instance of a chart, and you can tell it to upgrade that for v3. So that way v3 can manage it. And it's nice because it lets you do a dry one where it makes no changes. You can make the changes. You can make the change without deleting the Helm version 2 stuff. So Helm version 2 could still manage it. You're not like hooked into it. You can make sure version 3 got it and everything before you clean up. And then it has a capability to go ahead and clean up that version 2 one after you've verified it. Again, you can kind of see this conservative approach of not break folks, let them test it, let them verify before they move off v2. We want to make this experience easy. And so otherwise, but the plugin does the work for you. And we're very happy to have that in the Helm work. And so that is Helm v3 in a nutshell. What kind of questions we got? I'm happy to answer questions.
I am not seeing any off the bat, actually.
I don't have a question, but I have a general. The idea of being able to store all of our artifacts, not just the container images, but the everything in a single place, is so compelling and simplifies so much that yes, please. That's really all I wanted to say.
Yeah, so we've wanted this for more than a year. We've been working on this for a long time. Josh, one of the Helm maintainers, has been spending a ton of time working on it. In fact, there is now, so Deis was bought by Microsoft, but they have this great org called Deis Labs up on GitHub. And one of the projects they have is called Oras, O-R-A-S. And Oras is a library, excuse me, that lets you build tools to stick stuff into OCI registries. So if you had some other thing and you wanted to build an application and you want to just be able to stick those packages in there and pull them, you can actually use that library to build the functionality. And we actually use that in Helm. And yeah.
Isn't that CNAB?
No, this is Oras. It's different.
Okay.
CNAB actually uses it. Let me go find it.
Well, I see it like this.
Let's see. I will drop it. It's called Oras, and I'll drop it over into Orchestructure here. This is the package, and it allows you to build stuff to stick into OCI registries. Oh, the example uses GoFish. Okay. If you're not familiar, GoFish is another operating system package manager. It uses Lua to write your stuff, and then you can install it on different operating systems. But Oras is a place, yeah, Oras provides you the building block. So if you want to do things, and right now the holdup in the OCI is they're always very image heavy, right? And some of the companies have to figure out, what do you do? Folks like Docker, right? They have a deny list of all kinds of media types rather than accepting all media types, because otherwise somebody's, going to go stick a movie up in Docker Hub and say, hey, go download it, because that's what you do on the internet, right? Big object, big blob store, stick a movie in it. Share it with friends, share it between machines. So they've had to add, and I'm sure many of the other major providers have had to add layers in for security and to stop abuse. And being able to stick all kinds of other artifacts in there complicates that a lot. And so I imagine there's something from the operator side in saying, getting the thumbs up. The OCI started out of images, and the image spec folks have a lot to say, and they're very into their images. And so they've got an opinion of, no, this is an image thing. We like our image stuff. So there's something there. And so I expect to get the thumbs up soon, but I expected it like a year ago. I'm just more enthusiastic now than ever.
Yeah. Nice. I actually have a question. Is your the three-way patch diff thing, are you going to be using server-side apply soon instead?
I'm thinking. I have to go look at the code. I don't know the answer to that. So we wrap in order to do this, we wrap kubectl code, client Go code, API machinery code. We basically let the Kubernetes libraries do a lot of this work for us for any place that we can. And so it may depend on their code and using it. There are a ton of people using old versions of Kubernetes. I know financial institutions using things that are a year out of security support, right? There's tons of old stuff out there. And so we want Helm to be able to work with that to the best of our ability. And you really kind of need kubectl and some of the other tools to do that because there's so many old versions in use. People aren't upgrading as quick as they probably should for security and other stuff. So we want to have that support, but we do want to do things like server-side apply and things like that. I need to go look to see, but it may already be happening on the right clusters just because we're using the underlying Kubernetes packages to do it. That's a good question. I haven't looked at that code in a while.
Yeah, the nice thing is server-side apply should like resolve a lot of the weird like two people updating at the same time or the other various like race conditions that can happen.
Yep.
So I have a question, Matt. Do you still see a lot of people that are new coming into Helm? And, you know, of those people, what seems to be some of the most challenging thing to wrap their heads around?
Good question. And it's not what you might expect. So the most challenging thing that I see people have trouble with is Kubernetes. We get a ton of support questions that are Kubernetes general questions. People just don't know Kubernetes, how objects work, what the objects do. So they're trying to create a chart or they're trying to troubleshoot a chart. And they're trying to figure out these complicated sets. At one point, for Kubernetes 1.13, I think it was, I decided to take the Kubernetes API doc and I cut out everything that was deprecated, right? So just the latest versions. And I scoped it down to just Kubernetes objects you would use in your apps. And then I printed it to PDF at 8.5 by 11. I wanted to see how many pages I would have to print out the whole. This isn't general usage docs or anything, like that, just the API spec. And I thought I broke my computer. 5 minutes later, it had generated a 1,200 page document. There's just a lot to know. Let's be honest. There's a ton to know, right? If you start going through the general purpose documentation of how you link things together, how do you do workload tasks? There's so much to know and so much nuance to Kubernetes. I don't think anybody actually knows it. And so people come in with questions. Sometimes they're the hard questions, but often it's just the new questions because they're just onboarding and their route to the world is, hey, I got Kubernetes. I want to take something for a spin. I'll use Helm install to install something. Now poke around, maybe start making my own charts. But they just have general questions. And so that's probably the biggest thing we noticed. Why we even see there's so many new people coming too, is they're coming to Helm on their route to Kubernetes.
So, like it's sort of seen similar things with the various questions on like discuss the Kubernetes user forums. There's a lot of stuff like how do I install Kubernetes? What is this kubeconfig file?
Yeah. No, there's tons of questions out there, and the experience. I would personally like to see a lot of tools on top of Kubernetes that ease that experience. When I stumbled across the Cloud Foundry operator, I was blown away. I thought, there's a whole bunch of people who still do 12-factor apps who want Heroku in their own environments. Hey, Cloud Foundry, there's a Cloud Foundry operator I can just install. And in fact, I think it uses a Helm chart to install it. I can just install Cloud Foundry in my cluster, and my 12-factor app devs just have something Heroku-ish. Tools like this, I think, have a lot of opportunity to reduce some of that complexity, although it's not going to help chart author creators.
Gotcha. Yeah, thank you for that insight. That's really interesting to hear. People still aren't really sure how to get onboarded. I know the CNCF recently announced a training around Helm. Did you have any input on that, and what are your thoughts on avenues for people to learn Helm?
This is one of those things where I think I answered a couple of questions on it, but whoever created it, was it you? I'm trying to remember. I don't remember who created it now, but I was entirely busy and terribly delinquent in answering their questions, and I'm glad they had plenty of Helm people to bug when they were creating it. This is the kind of stuff that we need trainings on. because stuff's complicated and people learn through different ways. So the Helm project has a whole bunch of general docs, right? And you can walk through the docs and do it, but not everybody learns that way. And they learn through other means. And so I think it's fantastic that to have videos and other forms of training to help onboard people. I think we need that. And I also think we need, for many of the people who aren't going to dig into the Kubernetes internals and the complexities, some higher level tools and trainings on those. I'd like to see more of that in the CNCF as well.
Gotcha, that's awesome. Kind of on the CNCF topic, it looks like Helm actually graduated in April of last year. What do you think, as a key maintainer, as someone who's very active in the community, what do you think that's brought to the table in terms of Helm's growth and its ability to reach just a multitude of people entering into this community?
So the CNCF has this statement on maturity, right? So sandbox projects are kind of for the early adopters, right? And it's the crossing the chasm picture. They actually relate it to crossing the chasm. I actually have a document on that. Let's see if we can find it real quick. It's on their projects page. Let's see. Yep, here it is. On the graduating and incubating projects page, and I'll drop a link in the orchestration chat. They actually talk about the different projects in terms of crossing the chasm, right? Sandbox projects are for kind of the innovators, the techies, maybe. Incubating is kind of for the early adopters, and graduating is for that early majority, right? That's the way they kind of put it. And I think when you graduate or you hit incubating or those things, it's not like now you do it. It's now you've got your stuff together so those people are using it. But it's also kind of a stamp of approval, because when you get to the majority, they're more conservative about what they do, especially enterprises and things like that that tend to say, hey, I don't want fast moving things that break all the time because I got to build my business on it. And I'm slower because of regulatory. I got to fill in all this other stuff. And so I think graduated helps us move into to more potential users, I think it's Helm. In fact, we've seen growth. Actually, we've seen just amazing growth since Helm v3 came out. Back when we were at KubeCon Cloud Native Con North America, the last in-person conference, I said we had just crossed like 1 million downloads in a month. When we graduated in April, we had crossed 2 million downloads a month. Actually, like right at the time we graduated was when we crossed the 2 million mark. Just like that few months time, we've grown. I think the number now is like North America's 1.9 million downloads a month, right? There's just an immense amount of growth that's happening. And I think some of that may be graduated. And now people say, okay, we trust it a little bit more.
For sure, yeah, I definitely agree. So I think it's a level of trust, a level of understanding what some of the key players are in the area as they come in and they start to assess what to leverage. That's really awesome. So I actually linked your presentation that we had a copy of from when you came in 2018. It looks like it was October of 2018 at Ithaca, and that was really great. I think you talked, I don't remember exactly. I think you did a little bit about the charts repo, the chart museum, how we kind of funnel this public domain of working on these community-driven stable charts that everyone has come to depend on, really, especially even us, Nginx and Grass and multiple other for our core services. What's the future there? What's the worry there? And what are your thoughts?
All right, I totally should have put this on the slide deck. Thanks for bringing it up. Okay, so there's the charts repository. And the charts repository, when it started off years ago, probably back in 2015, it was examples. Other people, Helm was always designed around many repositories. That's why you have the Helm repo add command. It was, you could look at systems like apt, right? And apt, you can have lots of repositories. This was an example repository. But people wanted a central repository. People kept PRing new things in and new changes. And next thing you know, we had a central repo that we had to manage, which was a massive pain. We were actually running through maintainer burnout for a long time. See, you're getting the commentary, the color commentary. We were going through maintainer burnout. People would come in, they'd maintain for, like, oh my gosh, this is so much work. and they'd eventually burn out because it's hard when you got 50 and then 100 and then 200 charts and people coming in with all these ideas on what you should do with it and constant upgrades and things like that to them. And it just turned out to be a lot of work, and we were rolling through people. So we started layering in things, more CI testing. Anything we could automate, we automated. Some of it's Circle CI, some of it's still using the Kubernetes test infra stuff, and we'll actually use that to the end. And we layered an owner's file, let people own their own charts and make their own changes. But what we found is that whole model didn't scale well. And Helm is really designed around distributed repositories. So we created the Helm Hub, hub.helm.sh, right? And it's a place to search multiple repositories. And we wanted people to kind of branch off and manage it themselves, because the charts maintainers, and I'm one of them, ended up being blockers. We were slow. Some people wanted to use different processes, and we only had one process across everybody. It just wasn't a happy path. It wasn't a happy place. And so we said, hey, we're going to do hub.helm.sh, and we'll let you do your own. Well, when we also decided that we were going to deprecate Helm v2, we also said, Helm v2, right? If you do Helm init, which is gone in Helm v3, it's going to add the stable repository. So we could never get rid of that stable repository. And Google has so kindly hosted that stable repository for years, right? And now that we're in the CNCF, because this is all from before the CNCF even existed, right? This is a Google company thing, and they've done a fantastic job of hosting that for us. But we needed to get off of it, and we wanted people on their own repositories. And the Helm Hub helped us expand on that. And so we set an end of life for it. That's the same as the end of life for Helm version 2. It's going to be gone. And we're sad to see it go, but aren't going to miss all the work. Right? And so now we have a distributed world with hub.helm.sh where you can find, and people can distribute their own charts. And so Bitnami used to have all of theirs going to the stable repository. Bitnami now owns their own repository, and you can actually see like over 100 of the charts were theirs. And they've done all this fantastic automation and other stuff around it, but now they don't need to copy it in, and they can maintain it how they want to in their workflow and still distribute it to everybody. And so we have hub.helm.sh, which has some issues of its own. It's running monocular, which was really designed to be run on premise, not scale to thousands of charts and things like that. And so we're in the process of figuring out what we're going to do with hub.helm.sh. But my hope is actually there's this thing called the Artifact Hub. Are folks familiar with the Artifact Hub? Are you all familiar?
I think I've heard of it. I'm not really familiar with it, though.
So Artifact Hub is a new sandbox CNCF project. I just dropped the link into Orchestructure here. And you can find and install, publish, share Kubernetes packages. Now I say Kubernetes packages because you can do Helm charts in here. Helm charts were the original thing. But you can actually find operators by OLM. You can find some Falco rules in there. We're trying to make things that are CNCF packages, CNCF things, easily discoverable in one place. Because if you wanted to go look for something and say Google or a search engine, good luck. They give you 10 results. There's all these other things in there. You can't find it. It's a metadata. It's not like NPM where you push and pull things from it. It's just kind of an aggregate metadata of other things out there. But you can find a lot in here. Like if you search for Postgres, right? And you'll find things like the Postgres, you'll find the Postgres Bitnami chart. You'll find the Falco rule. You'll find the crunchy data PostgreSQL operator. And if you go to the Bitnami chart, right, it'll tell you how to install it with Helm. It'll tell you the information, and it'll tell you about related packages, such as the Falco rules, things like that, right? It's pointing you around to other things because the goal is to make discovery of those artifacts better. And it has a ton of neat features in it, right? So if you sign in and create an account, you can actually add your own repository here. You don't need Git or anything like that. We have with the Helm Hub. But you can do things like follow something. And when we discover an update, get an email that it's been updated. Or, this is my favorite, you can actually do webhooks. So you can say, ooh, I want to see when these packages are updated and have a webhook fired. Oh, I can have a webhook fired. So that means you can write automation when updates come in to these things, right? So it's got a bunch of neat features. It's still in the early stages, but it is a CNCF sandbox project.
That is awesome. Did not know about that. I knew about Operator Hub, which I believe Red Hat had provided, which was for operators, sharing operators. The interface looks very similar, but this is super exciting. That's really good to hear. Thank you for linking that.
So,
let's go ahead, Bob.
I actually have one question. This might lean more on the color side of things. This isn't necessarily Helm v2, v3, but how'd things go when Kubernetes deprecated the beta APIs?
Horrible for tons of people. Helm v2 had a problem with it because we were still using that at one point. The upgrade path isn't always a happy path, but there were lots of chart users and just lots of people in general who had trouble with that because they were using beta APIs. If you're trying to distribute something across a wide variety of things, it went GA in 1.9, but I mean, there's probably, at this point, I think I know of people on 8 different versions or 9 different versions of Kubernetes. And lots of people were still using the beta stuff. They were happy with it. They didn't think about it. Tons of examples and documentation out on the internet said use it. And so when it got turned off, lots of people broke all over the place and had install issues and upgrade issues. We had a bunch of support issues in the Helm issue queue. And yeah, it was wild. And that kind of says, for a long time, they didn't turn off any beta APIs because there was an original problem. Once stuff's written to disk, if you delete the APIs, what do you do with the stuff written to disk? So the way they actually did it was they just stopped taking in the new things. It's not truly and entirely gone. In fact, if you go and inspect the Go packages, you'll still find the stuff there. Kubernetes can still handle it to a certain extent. They just deny accepting it, right? And when they denied accepting it, so things came out in 1.9, supposed to be like 3 releases. So like in 1.12, they could have gotten rid of the betas. They waited till 1.16, right? So everybody was really comfortable for a long time. People weren't used to betas ever going away, and they felt very stable with them. And so there was a lack of comfort. Quite frankly, if you actually go through the documentation now in Kubernetes, little rant here, go find that page that tells you the deprecation cycle, whatever it is, and what you should do to upgrade. Go find it, the documentation, directions of what people should do. I dare you. And if you do, tell me, because I don't know where it is. I want to point people to it.
Okay,
right?
that's the challenge. That is the challenge. Yeah, everyone listening, do it.
For end users, right? If you're in the Kubernetes circle, you're always around it. You kind of know what's happening. You can track it down. I know email threads where some of this information's been shared. I've been on them, and Kubernetes community calls. But if you're like a general user, right? Because there's like a small group of people who work on Kubernetes, a larger group of people who operate Kubernetes, and then an even larger group of people, way larger, who run their stuff in Kubernetes. And that top group, right? You may get 1% of the people who are involved outside of that Kubernetes community, right, is in this, right? Like 99% is the bigger blocks, right?
Mm-hmm.
And they're not in those meetings. They're not on all those mailing lists following everything. And so clear, concise direction around this was kind of missing. And so I think that caused some churn and some issues.
For sure. Yeah, that's always bound to happen. Matt, thank you so much. This was amazing. How can people find you? What's the best way? Twitter, all those places. I'm Matt Farina. Really, really crazy name, right? Or I'll probably be hanging out in the orchestra room now in Slack if you've got questions there. Or you can find me in Kubernetes Slack or the CNCF Slack. I have to have a pretty beefy machine just for Slack.
Too many Slacks.
Yes, exactly. Yeah. Thank you so much, Matt. It's been a pleasure. We look forward to the next time, and yeah, we really appreciate it. So all of the resources will be linked for everybody, and thank you to Bob and Jeff and George for helping set this up. I couldn't do it without you guys. So thanks to everybody tuning in. Have a great evening. Attendees in the Zoom, stay on for just a minute. Thanks, everybody. Bye-bye.
Bye. Thanks.